The following is an alpha beta unsaturated molecule. It is called as acrolein, this one, and it's a monomer used in building polymers in plastic production, and you ought to provide a mechanism for the conversion of glycerol to acrolein when sulfuric acid and heat are used. So we know whenever you have an alcohol and sulfuric acid, the alcohol is going to be protonated and it will be converted to a good leaving group, which will lead to the formation of a carbon-carbon double bond. So that is what is going on here. So if you have H plus in the medium and you have a bunch of alcohols, it's easier to start with the alcohol in the middle, because if it leaves, it's going to be producing a secondary carbocation, and the secondary carbocation is more stable. Therefore, it is easier to start with the alcohol in the middle. Okay, so you produced your oxonium, and that is now a really good leaving group, and the loss of a leaving group is going to be possible, especially when the hydrogen here on the next carbon is kicked out as H plus. So you have a carbon-carbon double bond, an OH and an OH there. Now as you can see, this is an enol. This is an enol. So what happens is your enol is going to tautomerize, and the way tautomerism works is the OH bond is going to be used to do that. So it's an rearrangement if you look at it. Okay, and you have an alcohol in the beta position, and there is still a lot of acid in the medium, so one more protonation is in order, and one more oxonium ion is going to be possible. Now this also is a good leaving group, and previously this carbon had one hydrogen, and with the tautomerization, when it becomes an aldehyde, you have two hydrogens. You can take one of the hydrogens and again use those electrons to allow the elimination chemistry to happen, and now you have a double bond and you have an aldehyde that is going to be conjugated. So alpha beta. So alpha beta unsaturated aldehyde is how you will get from this mechanism for the formation of acrolein from glycerol.